Good morning, students. In the previous video we had discussed precisely regarding basic and initial concepts of LPP, including the procedure of graphical method. Let us recall the procedure of graphical method of solving LPP first. What was it? First and foremost, treating each inequality in the constraints as equalities. For each equation, finding out two sets of points. Two sets of points is nothing but by putting x equal to 0 in an equation, finding out y value. By putting in y is equal to 0, finding out x value. After obtaining these two sets of points for all the equations, plotting those equations obtained on the graph and joining the respective points to obtain straight line. Here, joining respective points have to be majorly concentrated. Next, after that, what was to be done? Identifying and shading the feasible region was required. By this time we are aware already that what is feasible region. The region which is being satisfied by all the constraints, including non-negativity restrictions, will be called as feasible region. Once when we are telling very clearly non-negativity restrictions are to be followed, then certainly it lies in first quadrant. And one more fact we are aware already, that in order to find out feasible region, if in case less than or equal to type of constraints are given, then towards the origin we will be coming to find feasible region. If by chance it is given greater than or equal to, away from the origin we will be in search of feasible region. So put together, in total, feasible region is the common area found in first quadrant which is satisfied by all the given constraints. Fine. After identifying feasible region, what has to be done? Identifying the corner points of the feasible region has to happen. First identifying the corner points and then coordinate points. Proper coordinate points have to be written for corner points of the feasible region. While writing corner points, coordinate values, x, y format have to be properly followed. First x coordinate value and then y coordinate value has to be written. After writing corner points coordinate values, what is to be done? Those corner points coordinate values may have to be put in objective function to get evaluated. I mean, evaluation has to happen by putting in all those corner points coordinate values in objective function. After solving for each coordinate values, we would be getting various z values. After that, what was to be done? Basing on the given problem, whether it is maximization or minimization, among the available values of z, inference has to be obtained. That means result may have to be written at the end answer. If in case maximization is given, then among available z values, the maximum one may have to be chosen and the respective coordinate values will become optimal solution. If in case it is minimization problem, then the minimum value among the z values available may have to be found out, that respective values, the respective coordinate values will become optimal solution. And we have come across multiple solution, no solution, unbounded solution, all such cases already in the previous video. Let us see in some of the problems of graphical solution we will come across all these categories. So in this particular video, let us consider the continued version of LPP, that is solving numerical examples based on graphical method. One problem I'll solve by explaining thoroughly, listen properly, understand the procedure so that remaining problem solving will become very easier for you. Take graph sheets if you have, otherwise draw on the plain papers and practice the problems, including the ones which are solved in the videos are to be practiced. Keep your notes updated. All exercise problems must be neatly solved in a separate statistics notebook. Not only homework problems which have been assigned, all the remaining problems, including the ones which have been solved or explained in the video, to homework problems, to any other remaining problems may have to be worked out neatly once after lockdown is over. Once when college reopens, at that time certainly each and every individual student's notebooks will be checked. Okay. Let us get into first problem of linear programming problem solving using graphical method. This is question number 13 in your exercise. The question is, graphically solve the following LPP. Maximization of z equal to 3x plus 5y, subjected to x plus 2y less than or equal to 200, y is less than or equal to 60, and x comma y greater than or equal to 0. You can recall the previous video's explanation and the way how we have solved problems basing on the formulation of LPP. So it's already formulated LPP given here. It's asked to solve for this LPP using graphical method. Fine. So maximization of z equal to 3x plus 5y, what it is given, it is called as objective function. S dot t, in the sense it is subjected to or subject to. X plus 2y less than or equal to 200, y less than or equal to 60. These both are given linear constraints. And lastly, what it is given, x comma y greater than or equal to 0, it is called as non-negativity restrictions. Well, so in this x plus 2y less than or equal to 200, both the decision variables have been included. But in case of second constraint, only one decision variable y is considered. The other variable x is not being considered. It might be like, 0. That's why it has not been mentioned. Or certainly it will be treated as x equal to 0. That's why it is not being mentioned in the second constraint. Only y matters there. That's why y is less than or equal to 60 has been given. To solve graphically the given linear programming problem, we have discussed already the procedure in the previous video also, and in the beginning of this video I have asked you to recollect by explaining once. What is the first and foremost step in order to solve graphically the given LPP problem? The given linear inequalities are to be considered as equalities and sets of points to obtain straight lines in the graph we need to get. So let's see how it can be done in the next slide. In terms of solution, consider all constraints or inequalities as equalities and obtain coordinate points as shown below. First constraint, look at the cursor for better understanding. First constraint, in the problem what it was given, x plus 2y less than or equal to 200 it was given, but as it is being mentioned, first step it is to be considered equality first. So equality is being considered here, x plus 2y is equal to 200. And second constraint, y less than or equal to 60 was given, that is being taken as equality, y is equal to 60. So in terms of calculation of sets of values using first constraint, when x equal to 0, what will be the y value? When x equal to 0, this term where the cursor is being revolved, this term goes as 0. Only remaining is 2y is equal to 200. At that time, y is equal to 200 divided by this 2. It becomes 100. So that once when x equal to 0 is there, y is equal to 100. And after that, once when y is equal to 0, what happens? This 2y term will be equal to 0. So that remaining is x is equal to 200. So that x equal to 200 is being written here. So once when y is equal to 0, it is x value is 200. Then in the second constraint, y was given as less than or equal to 60. So it is made as y is equal to 60. After that, there is no need to mention once when x equal to 0, what is the y value. Once when y is equal to 0, what is the x value. Just because only one decision variable is involved in this, that after equating the value of y we have got already is equal to 60. That's why that formal procedure will not be applicable for this particular constraint. In fact, it is not applicable whenever only one decision variable has been specified. Even in case if here x is greater than or equal to 70, that kind of constraint is given by chance, then x equal to 70 we would have taken. Their substitution of both x equal to 0 and y equal to 0 is not necessary. Then lastly in the question it was given non-negativity restrictions, that x greater than or equal to 0, y greater than or equal to 0. That greater than or equal to inequality, once when it is being brought to equality, it will be x equal to 0 and y equal to 0. Here we have mentioned that non-negativity restrictions which was given in the problem. By equating we are writing here x equal to 0 and y is equal to 0. So first step is over. Then second step is using these values which have been obtained, plotting on the graph and obtaining straight lines between the obtained points has to be considered. So now for a plane axis x and y, if these values to be considered for drawing, we may have to put in proper scale first, as we all know. So x-axis and y-axis scale has to be decided basing on all these values. Better to observe both x values and y values, which are the minimum and maximum values. Basing on that, proper and ideal scale can be set. First, x value if we see, x equal to 0 is the minimum and x equal to any value 200 is there. After that, any other values are there greater than 200? No. So x equal to 200 is the greater value, I mean to tell the larger value. X equal to 0 is minimum value and x equal to 200 is maximum value. So if by chance if I am taking x equal to, I mean x axis 1 centimeter is equal to 10 units, then it would become 20 centimeters. It may not become possible to observe sometimes in our paper sheet 20 centimeters. Better to adjust in scale. Instead taking x equal to 10 units, it can be taken 20 units. If you take 20 units for x-axis 1 centimeter, within 10 centimeter the work will be over. So better in that way, considering the axis, scale. Then y value, y is equal to 0 is minimum, and y maximum value what it is, y is equal to 60 is here. More than that, yes, y is equal to 100. So that y is equal to 0 is minimum, y is equal to 100 is maximum. If I am taking here y axis 1 centimeter equal to 10 units, 10 centimeters are required. Fine, not an issue drawing 10 centimeters on our graph sheet. Better to take y axis is equal to 1 centimeter is equal to 10 units. Fine. Let's see how it can be done. X and y axis we have plotted, and as it is said, the x-axis and y-axis scale accordingly it's written over here. So x-axis is equal to 1 centimeter equal to 20 units. Here this is x-axis, look at the cursor, 20, 40, 60, 80 till 220 we have written, and y-axis 1 centimeter is equal to 10 units is taken. Here on this y-axis 10, 20, 30, 40, 50 till 100 has been considered. And this is what is title which has to be written for every problem as graphical representation of LPP, linear programming problem. And after this, what is to be done? The obtained points, sets of points may have to be plotted on the graph sheet, to tell on x-axis and y-axis, and respective values are to be joined in order to get straight lines first, correct? Fine. Let's see how it can be performed. Here again look at the cursor. Towards right side, x plus 2y is equal to 200. This is the constraint for your reference it's being given. Once when x equal to 0, what was it? Y is equal to 100. So y is equal to 100 where it is? Y is equal to 100 is here. Look at the cursor, correct? X equal to 0. On y-axis, x is equal to 0. You know that already. If you want clarification, let it be understood in this way. Look at the cursor. Here, where the cursor is there now, this is origin. 0, 0 is the coordinate value for this origin, correct? And then on x-axis, if you are seeing x equal to 20, y is equal to 40, x equal to 20, x equal to 40, x equal to 60, x equal to 80, x equal to 100, all these values are x values, correct? Because they are lying on x-axis. What is the value of y on this x-axis? Observe here. Y equal to 10 here, isn't it? So if I am taking one more straight line here, then there y value will be 10. Here at this point, in origin 0, 0 is there. At the value of 0 itself, here the line has been taken for y-axis. To tell y values. So y values are there here as 0, and here 10, here 20, here 30, here 40, in that way. So that on x-axis y values are 0. By chance if it is taken, look at the cursor here, by chance I am taking the value over here at x equal to 40. What is the coordinate values for this? As I have said, x comma y format it has to be written. X value is 40, so that first value will become 40. What is y value for this? 0 we said just now. So 40 comma 0 is the coordinate value for this particular point. If by chance here I am considering, look at the cursor properly, if by chance here I am considering any point, then what it would be? What it would be the coordinate point for that? Here I am asking you to concentrate on. X value, see x value here, it is at 40. And at the same value, if you are taking y value, what it is? 10. If I am taking the point over here, x value and y value respectively, if I am observing x equal to 40 and y equal to 10. By chance here it is to be written, then 40 comma 10 it must be mentioned, because x comma y is the format prescribed. Fine. So in the similar way, on y axis, what is the value of x? See here, if I am taking 20, here one line, okay, here one particular line, if I am observing, what is the value of x here? 20 on this particular line. And if I am taking one line here, on this particular line, x equal to 40. If we have to observe at this particular line, what is the value of x? At the origin, 0 we are starting. See, 20 if we are starting, on this line 20 I said. 40 if it is on this line, 40 will be the value of x. But here it is on this value, this line we are observing now, what is the value of x? X value on this line will be 0, because at origin level only the straight line has been observed, and it is a y-axis, so that x values will be 0 on this particular y-axis. That's why for this first value, look at the cursor, x equal to 0, y equal to 100 was there, y equal to 100 where it is? Here y equal to 100 is there, and at this line anyhow x equal to 0 already. That means on this line x equal to 0 already. That's why for this point, coordinate values have been written as 0, 100. X value is 0, y value is 100. After that, y is equal to 0, x equal to 200. X equal to 200 where it is? Here, look at the cursor. X equal to 200 is here on the x-axis, and we know already on x-axis y value is equal to 0. So what is the coordinate value for this? X value first, that's why 200. Then comma y value has to be written, y value is 0 on x-axis. That's why 200 comma 0 will be the coordinate points for this particular point. And after these 2 points have to be joined using straight line. See, the straight line has been observed using these 2 lines. And what equation the straight line is representing now? X plus 2y is equal to 200. That's why that specification has to be given here. This line is nothing but x plus 2y is equal to 200. Once after drawing any line, any multiple lines on the graph sheet, better to mention nearby that line which equation that it is indicating. It's always better. Otherwise later we may get confused in order to go either less than or equal to or more than or equal to format towards the origin and away from the origin. When we are going for feasible region finding out, it would become very difficult. That's why it's always better and in fact compulsory to write this particular equation nearby the specified or nearby the respective straight lines. For all the straight lines it has to be written. Fine. After this, second linear constraint has to be taken. What is it? Y is less than or equal to 60. And equation, if I have done it, y is equal to 60. Y is equal to 60 where it is? Here. Only y is equal to 60 has been specified, so that we have kept here. And x value is not given. It is nothing but x equal to 0 and 1 on this axis. Anyhow x equal to 0 it will be, correct? Fine. So let's see in the next slide. Y is equal to 60 has to be plotted, so that y is equal to 60 is here. One perpendicular line to the axis y or parallel line to the particular axis x has been drawn at this particular value. Y is equal to 100. Sorry, y is equal to 60. Now that representing equation also has to be written nearby this particular line. Y is equal to 60. Okay. And x equal to 0 and y is equal to 0. One more. We have just now understood on y-axis x equal to 0, on x-axis y is equal to 0. So if I am considering this particular line, already it is y is equal to 0 line. And if I am considering this particular line, then it is already that x is equal to 0. So these two constraints, non-negativity constraints, also have been considered already in the graphical representation in the name of x-axis itself and y-axis. Okay. Both the sides in the given question, it was given x plus 2y less than or equal to 200, y less than or equal to 60. Both are given less than or equal to kind. That's why towards the origin I may have to come in order to find out feasible region. So here x plus 2y less than or equal to 200, if I have to see, on this particular line, already it is equal to x plus 2y is equal to 200 is there on this line. Less than or equal to in the sense towards the origin I have to come. That's why these small little lines have been mentioned inside or towards the origin. Origin is here. Towards the origin, if it is to be written, like small little lines have been shown on this particular way. And then later y is also less than or equal to 60 was given. Y is equal to 60 on this particular line, less than or equal to in the sense towards the origin. For this line, origin is this side, towards the origin means again less than or equal to, towards the origin it has to be mentioned. Small little lines are giving you the indication where or which direction we may have to observe. Fine. Now, in order to find out feasible region, common area which is being satisfied by both the constraints, we have to finalize. By chance, look at the cursor. If we have to see this particular area which I am showing with the cursor, whether it will be feasible region, we have to see. This region is less than or equal to anyhow 60, but this region is not less than or equal to x plus 2y is equal to 200. That's why this is violated. And then here, this triangle, if I have to observe, this area is less than or equal to this particular line. Look at the cursor. But it is not at all like less than or equal to for this constraint. If greater than or equal to is there, towards this side we would have come. Correct? But it is less than or equal to, that's why towards the origin we are coming. So this is also not the common area. So which is the common area? You can get visualized. You might have understood already what is the common area. Look at the cursor right from here to here. It is the common area which is to be termed as feasible region, feasible area or feasible solution. Better to shade feasible solution. Let us see in the next slide how it can be shaded and shown. Observe here. Here this particular area has been shaded and shown as feasible region. After this, what has to be done? Corner points may have to be observed. So for this feasible region, which are the corner points? Look at the cursor. This is one corner point and one more is here. This is one more corner point and one more here, this corner point, and one more this side, the corner point. After finding out corner points, let us write coordinate values for those points. Here O, A, B and C, let it be the feasible region. Then for origin, what is the coordinate value? 0, 0. And here for this A, what is the coordinate value? A is at 200 in x-axis, so that 200 value has to be written, first x value, then comma, what will be the y value on this particular line? We have understood in the previous slides, it will be 0. That's why x first value has to be written, 200 is written, comma, next y value has to be written, 0 has been mentioned. So for A, 200, 0 is coordinate values. And then for further, first let us consider C here. What is the value of x over here? It is y-axis, so that x value is 0. Let us start with 0 first, because it is x value, 0, comma. What is the value of y here? 60 itself. So 0, 60 is the coordinate value for C. And after that, this B, how to write this coordinate points? See, for O and A and C, the points were lying on the lines itself, x and y lines itself, the values were falling. So easily we had written 200, 0 or 0, 60 or 0, 0. In this way we had written very easily. Here in between the graph, if any value appears, it is little difficult to get accurate answer basing on, if I take the procedure of x value for this particular point, x value means x where it will fall, 80, fine, x equal to 80 is given, and where it will fall on y-axis, exactly equal to 60 it falls, so that 80, 60 is being written as B coordinate value. This is one of the procedures, but always this procedure will not be working out, just because here it is given 50 to 60 as 10 centimeters. Here it is given 80 to 100, 20 centimeters. By chance here in between the value happened to fall, then we may consider here 90 if it is happening exactly in middle, or else here also we would take in between values. So in between values, when we have to take, sometimes one user may take one way, the other user may take in another way found values basing on their observation. That's why this procedure need not be followed, but one more, an important and which will be helpful for all the problem solving procedure has to be followed. Listen to me carefully. Where is the cursor? You can observe. Here is the point B. For this, coordinate value has to be obtained. In order to find out coordinate values for this or any other point wherein in between or in the area of the graph it falls, how to find out coordinate values? Here for this B point of intersection, which are the two responsible straight lines that has to be found out. See, anyhow two straight lines only are there in this particular problem. This is the one straight line and this is one more straight line making this particular point. So these two equations are to be solved simultaneously. Y is equal to 60, x plus 2y is equal to 200 in order to get x and y values. Let's see how it can be done in the next video. Next slide. So coordinate points of B, solving simultaneously the equations of point of intersection of B, we get. So the point of intersection responsible equations were these two, x plus 2y is equal to 200, y is equal to 60. You know already how to solve two equations simultaneously. So here any of these decision variables may have to be cancelled by adjustment, and then the remaining value of x can be calculated, and further, like by putting in x value in any of the equations, y value also can be found out. You can observe here it is 2y, here it is only 1y. If I am making this also 2y, by changing the equation signs here, by changing the signs, these plus 2y and next minus 2y will be getting anyhow cancelled, only x will be remaining. In that case, to make this y to 2y, let us multiply this equation by 2 and let this equation be as it is, so that multiplied by 1. What happens? First equation as it is to be written. So x plus 2y is equal to 200. There is no change in it. And then y is equal to 60 was given. Now it will become 2y by multiplying 2, and 60 becomes 120. After changing the signs, this 2y and this 2y gets cancelled each other and becomes 0. And after that, x alone is remaining, that is written over here, and 200 minus 120. 80 will be the answer, that x equal to 80 has been given here. And after that, one more, this x equal to 80 has to be substituted in first equation, because x as well as y combination is here. Better to put in this x value is equal to 80 in this particular equation. So x plus 2y is equal to 200. X value to be written as 80 plus 2y is equal to, once again, 200 as it is. So 2y is equal to 200 minus 80. 2y is equal to 120 and y is equal to 120 divided by 2, which is equal to 60. Y value is 60. So what we have obtained, x equal to 80 and y equal to 60. So that in terms of coordinate values, first x axis value has to be written, or x value has to be written. So 80 has been given here, and then next 60 has to be written. So coordinate points for B are 80, 60. In one more way it would have been solved. Y once when it is given clearly y is equal to 60 without any other decision variable, then y is equal to 60 is certain. Even after calculation also we have come across y is equal to 60 only. You can look at the cursor. So before that also it is already y is equal to 60. This y is equal to 60 can be substituted in the first equation. 2y, that means 2 multiplied by 60, it is 120, and after that only x is remaining here. X can be retained as it is. This 200 is towards right side, and this plus 2y, y being, what is the value of y now? 60, isn't it? This 60, if I am considering 60 multiplied by 2, 120. So this 120 becomes minus this side, 200 minus 120. Then what will be that? The value of x will be equal to 80. It has been already found out. X is equal to 80. So no need to follow it like lengthy procedure for this particular problem. How I am telling now, that way also it can be solved. But why I have mentioned this much of lengthy procedure is, the other problems when you are solving, it would be easier for you. In case of x and y, both have been mentioned as the decision variables. How to calculate by solving simultaneously the equations, you must be aware. And moreover, from at least higher primary to secondary level to 10th examination, you have come across these solving simultaneously two equations very often. Fine. We have got now all the corner points coordinate values. Fine. Further, what is to be done? Those are to be substituted in graphical representation. So corner points, maximization of z is equal to 3x plus 5y. These are the corner points O, A, B, C, and these are the points written. Maximization of z equal to 3x plus 5y is the objective function. So here look at the cursor, 0, 0 for O. This x will become 0, this y will become 0, 3 and 5 will be as it is. So totally this will become 0. And then A, 200, 0. Here 3 multiplied by x, 3 multiplied by 200 plus 5, this 5 multiplied by y. X as well as y both are substituted over here. Once when y value has been substituted as 0, 5 multiplied by 0 is 0 and 3 multiplied by 2 is 6 and this 100, so that's 600. So totally 600. And then the third corner point we can come 80, 60. Here 3 and 5 as it is I have said, 80 plus 60. So 80 multiplied by 3 is 240 and 5 multiplied by 6 is equal to 300. Isn't it? So what it becomes? This 300 plus this 240. So totally it will become 540. And then for the equation C, 0, 60. X equal to 0, y is equal to 60 and 3 and 5 as it is from the equation. So this entire term goes as 0, 5 multiplied by 60 which is nothing but 300. Since the example was given as maximization problem, among these z available values, which is the maximum, we need to say 600 is the maximum, so that the respective coordinate values A 200, 0 will be like optimal solution for the given LPP. That's why therefore optimal solution to the given LPP is 200, 0 with maximum value of z equal to 60. Sorry, 600. See, maximum value is 600 over here, isn't it? So with the maximum value of z equal to 600. So this is what is the solution of given linear programming problem. Next problem we can observe. Question number 14. Solving graphically the given linear programming problem. Maximization of z, which is equal to 20x plus 80y, subjected to 2x plus 6y less than or equal to 60, x plus 4y less than or equal to 32, x comma y greater than or equal to 0. Again the same procedure. Inequalities have to be considered as equalities and two sets of observations have to be found out. Let's see how it can be worked out. Again, considering all the constraints or inequalities as equalities and obtaining coordinate points as given below. What was given in question? 2x plus 6y less than or equal to 60 was given. Let us equate it to 60. And second constraint, x plus 4y, again it was less than or equal to 32 given. So let us be equating it first. Here, look at the cursor. In this first constraint, when you put x is equal to 0, what happens? This entire term has gone to 0. 6y is equal to 60. So y is equal to 60 divided by 6. It will become 10. When x equal to 0, y is equal to 10. When y is equal to 0, what happens? When y is equal to 0, this term goes to 0. Then x equal to 60 divided by 2 it will be. Certainly it will be 30. Once when y is equal to 0, x equal to 30. Similarly here also x plus 4y is equal to 32. X is equal to 0. y is equal to 32 divided by 4, which is nothing but 8. Once when y is equal to 0, next once when y is being considered as equal to 0, then this term 4y goes 0. Only remaining is x equal to 32, that is being written here. So once when y is equal to 0, x equal to 32. Graphical way of representation of LPP goes in this way. As I have said, one problem thoroughly I'll explain you. Further it will be very much helpful for you. So this particular second problem I have not explained so much in length how I did in first problem solving. Here I'll just give you the explanation how all these values have been obtained and how it's plotted, what is the gist behind that, everything I'll just be explaining you once. Listen properly. Z equal to 20x plus 80y was given. Look at the cursor towards the right side. For your reference, the question has been given. Subjected to 2x plus 6y less than or equal to 60. Once when we have considered here is equal to 60, like 2x plus 6y is equal to 60 it would become. After that, x equal to 0 means what it will be? Y is equal to 10. Correct? So y is equal to 10 and x equal to 0 will be here. See, x value is 0 here and y value is 10. Look at the cursor for your understanding. Then y is equal to 0 if you put, what will be x value? It will be 30. Correct? That 30 here it is taken on x axis because x equal to 30. See, look at the cursor. Look at the cursor. Here it is 30, 0 because 30 is x value. Y value on x axis will be equal to 0. This is 30, 0. Then these two lines have to be, these 2 points have to be joined with a straight line. After doing that, here representative statement has to be written, representative equality. This particular line is nothing but 2x plus 6y is equal to 60, that particular manner. And after that, second constraint when you see x equal to 0 if you put, look at the cursor once again, right side. X equal to 0 means what is y value? Y value is equal to 32 divided by 4. What it will be? 8. Am I correct? So that 8, what is the value of 8? Y value is equal to 8. So that y value is 8 where it is. Look at the cursor here. Y value is 8 here. On this particular line y axis, certainly we know x coordinate value will be 0. So that here 0 first as x representative and comma this y value exactly 8. This way, these 2 points once again it is to be joined. So both the constraints are over, obtaining sets of values is over, drawing the straight line is also over. Again, let it be written representative line for this straight line also, representative equation. X plus 4y is equal to 32. This also let it be written. And according to the question, if you observe, see here the cursor less than or equal to is given for both the constraints. Less than or equal to in the sense towards the origin, isn't it? As I've explained in the last example. So both the sides it is given as less than or equal to. So towards the origin it has been marked. If you see, observe, like with small lines. So common area, which is that, see, look at the cursor. This is what is the common area which is being followed by non-negativity restrictions and all the constraints. correct? That common area, let it be written as feasible region. See, very carefully you can observe the cursor. Here one narrow triangle is there. This is not being considered in feasible region just because you can observe keenly for this particular line which I am showing now. For this particular line it is less than or equal to, but for this particular line, one more, which I am observing here, or which I am asking you to get complete clear cut idea. For this line, like it is not less than or equal to. For this particular line, this is less than or equal to. For this line, it is not less than or equal to. It is greater than or equal to for this line, this narrow triangle. That's why we will not consider it to be a common region. Common region is nothing but this much. So O, A and C and D. B was this side. We have not considered it under feasible region. So here anyhow 0, 0 origin, and here what it happens 30, 0 because 30 is the value of x and y value is 0. So that y value is 0 on x-axis. So here at this particular point a is equal to 30, 0. And after that here one more d. What is the value of y here? 8. That is well known to us. And on y-axis x value will be equal to 0. X, y format if it is to be written 0, 8 may have to be mentioned here. And as I have said in the previous class, previous slide to you, any in between the graph, in between the area of the graph, any points appears, better to solve simultaneously for that intersection of point, which are the two lines, possibly a reason to get point of intersection. Those are to be simultaneously solved. This is now 2x plus 6y is equal to 60, x plus 2y is equal to 32. These two equations may have to be solved in order to get this value. Already calculated and written over here 24, 2, but you may have to calculate and write it whenever it is required. Okay. So now let us observe how we will be able to obtain C coordinate values, and after that all these coordinate values let us put into objective function. So coordinate points for C point, simultaneously solving these two equations mentioned over here. So better here also, if I have to cancel x values, here it is already 2x and here it is x, so that let it be multiplied by 2. The entire equation has to be multiplied by 2. So first is as it is, since it is being multiplied by 1, 2x plus 6y is equal to 60, and here again 2x plus 8y, because 2 multiplied by 4 and then y, 8y is equal to 32 multiplied by 2, 64. So changing the signs, 2x and 2x got cancelled because of plus 2x and minus 2x. Here it is 6 and then minus 8y, 6y minus 8y. So bigger value is 8, which is having negative sign. That's why the answer will be the difference of these two with negative sign. It's minus 2y now is equal to 60 minus 64. Here also the same case, 64 is bigger magnitude with minus, so minus 64 plus 60 will become minus 4. Y is equal to this negative and this negative has been cancelled. Y is equal to 4 divided by 2, y is equal to 2. That's what has been concluded. and this y is equal to 2 may have to be substituted in any of these two equations. In fact, these two equations it has to be substituted in order to get value. So y is equal to 2, which has been obtained. Here I am putting in 2x plus 6y is equal to 60 in that. So 2x as it is, 6 as it is, y value has been found out equal to 2. So 2 has been mentioned over here is equal to 60. 2x as it is, 6 multiplied by 2, 12 is equal to 60. Then 2x is equal to 60. This minus 12 will become 48. X equal to 48 divided by 2, x equal to 24 will be the value of, like, x coordinate value. Since the procedure is to write x comma y values, first x to be written as 24 for this C, and then remaining y is equal to 2 has to be written, and then close the bracket. So you can observe the previous slide once again. Here C is equal to 24 comma 2 itself we had written. After calculation we had written over here. Okay, let us get into the same slide. Well, now C is equal to 24 comma 2. These are the coordinate values for the corner point C. Then feasible region is OACD, that was also already observed. You can see the previous slide. See here. O, A, C and D. B was not at all included. B was separate here this side, so that in feasible region it is not coming. That's why this B has not been included. O, A, C and D was feasible region. So that's what is being mentioned here. Feasible region is OACD. Okay, next slide. What is to be done now? All those coordinate points of corner points of a feasible region may have to be substituted in objective function. Let's see. So corner points are these. Maximization of 20x plus 80y is there. X and y respectively may have to be put in all these. From these coordinate points, put in x and y values in this by taking 20 and 80 as constant values. Just x and y have been substituted according to corner points. And z evaluation after that. For example, 20 multiplied by 0 is 0 plus 80 multiplied by 0 is again 0. So 0 plus 0 is equal to 0. This way, here 30 comma 0 is there. 30 and 0 respectively x and y values have been substituted. This 20 and this 80 is remaining as it is. 80 multiplied by 0 in the sense it is 0. So 20 multiplied by 30. 20 multiplied by 30 has to be done, which is nothing but 600. In the similar fashion for C and D, when you calculate, it will become 640 and 640 each. You can pause the video whenever needed and look at the calculations for better understanding. Now, since the given question is maximization kind, among these available Z values, maximum value I have to search. 0, 600, 640 and 640. 640 is the maximum value, but it is appearing twice. Both the sides it is to be mentioned as maximized value and maximized value. Though the corner points coordinate values are differing, but 640 and 640 is same in terms of answer. See, 24,2 are the coordinate values and 0,8 are the coordinate values, for which we have got 640 as Z values. Fine, not an issue. So bigger values or maximized values are twice in this particular problem as 640, these respective coordinate values will become optimal solution, which is nothing but C 24,2, D 0,8. That's why in the conclusion it is given optimal solution to given LPP is a multiple solution, because if it is equal to 2 or more than 2 times either the maximized value or the minimized value we are getting, we will be terming it to be multiple solution. Here at least equal to 2 times it's there. That's why it's being referred to as multiple solution. With 2 optimal solutions, one is C 24,2, D 0,8 with maximum Z value is equal to 640. It is maximum Z value is equal to 640. This is what is the solution for the next problem which we had considered. Let's move into next problem. Question number 15. Maximization of Z equal to X plus Y subjected to X plus Y less than or equal to 1 and 3X plus Y greater than or equal to 3, X comma Y greater than or equal to 0. Once again the same procedure may have to be observed. Equalities they have to be considered, the given linear inequalities as constraints, and then plotting 2 values on the graph sheet. Let's see how can it be performed. As I have already said you, first problem alone was briefly, thoroughly, it was explained. Here I'll ask you to understand properly based on the given question. I'll be giving you the hints and major steps how it has been calculated within one slide, but you have to concentrate cautiously and practice well so that it is not at all a big task to be completed. Here in this slide, look at the cursor. For your reference, I have given the question number 15 this side, right side. And after that, if I am considering X plus Y is equal to 1, first constraint, look at the cursor. X plus Y is equal to 1 if I am considering. See, X equal to 0 if I put, Y is equal to 1. Y is equal to 0 if I have to put, X equal to 1. So 1 comma 1. Or when X equal to 0 is there, then Y is equal to 1. See, Y is equal to 1 once when X is equal to 0 on this axis. Then after that, Y is equal to 0, X value will be 1. X value where it is 1, X value is 1 here. Look at the cursor. So here anyhow Y is equal to 0 on this line. So these two lines have to be added or joined to be written the indication of this line as X plus Y is equal to 1. And one more in the similar fashion, 3X plus Y is equal to 3. X equal to 0 if you put, what it will be? Y is equal to 0. 3. Y is equal to 3 is remaining. So Y is equal to 3 where it is? Here it is Y is equal to 3. Certainly on this axis X equal to anyhow 0. So Y is equal to 3 has been plotted here, and then later if Y is equal to 0 here, what will be X value? Y is equal to 0 means this goes as 0. 3X is equal to 3 is remaining. X is equal to 3 divided by 3, which is equal to 1. So that again the same point 1 here on the x-axis. So these two values have been joined by straight line by writing 3x plus y is equal to 3, the representing equation. So look at the problem first. Given problem, x plus y less than or equal to 3. So this equation, if we have to see, here it is given less than or equal to. That's why first with the smaller lines I have drawn here indicating towards coming towards origin. And away from the origin we have to go once when greater than or equal to is there. Second constraint is greater than or equal to. That's why small little points have been shown first, and then later with the bigger lines also it has been drawn indicating away from the origin. Now we have to observe, is there any common region in the first quadrant? In this particular first quadrant, will there be or is there any common region which is being satisfied by all the constraints? All the constraints in the sense, these two given constraints. Whether any common area is needed, it's present. No, obviously, because for this particular equation towards the origin, for this another equation away from the origin we are going, how can it be happening to observe common area between these two constraints? So common area is not there. Common area is not there in the sense, what does it mean? Feasible region is not there. Once when feasible region is not there, we will not be able to evaluate using corner points of feasible region in the objective function given. We will not be able to perform that. So once when feasible region is not there, there is no solution for the LPP. That way the conclusion would go. You can see here, as there is no feasible region or common region, there is no solution for the given problem, or the suggested solution for the given LPP is no solution. Okay. Here, basing on the values, x-axis and y-axis values were put, you can cautiously observe once again this solution. Okay. Next problem we shall concentrate on. Question number 16. Maximization of z equal to 2x plus y subjected to x minus y less than or equal to 10, then 2x minus y less than or equal to 10. And non-negativity restrictions are there as x, y greater than or equal to 0. The procedure is again repeatedly same. We need to consider linear inequality given. That means constraints given as equalities first and sets of values have to be obtained. Once when minus sign is there, here you can observe x minus y and then 2x minus y. That way minus, once when it is being given, you may have to be extra cautious while taking even the values, sets of values, or while plotting the values in the graph. In any step, you may have to be extra cautious once when it's the combination of positive sign and negative sign, the given problem. And let us see how can it be performed. The solution goes in this way. Let me explain what way the solution has been given. It's better to concentrate on the cursor, not to worry about rest part, what it is being found on the screen. All these you need not worry about. Where the cursor is, you can observe that and learn properly so that very well you can understand clearly. The given problem I have taken here right side. Look at the cursor for your reference. In this, x minus y less than or equal to 10 was given. If you equate it, what will happen? X minus y is equal to 10. Then once when x equal to 0, what is remaining? Y is equal to minus y is equal to 10 is remaining, which is nothing but y is equal to minus 10. Correct? Y equal to minus 10, where it is on the graph, you can observe here. Look at the cursor. Y is equal to minus 10. And then on this y is equal to minus 10 on y axis, anyhow x is equal to 0. Fine. Once when y is equal to 0 is being put, what will be the value of x? X equal to positive 10, correct? So positive 10 for x-axis where it is here. So these two values have to be joined using straight line. And indication has to be written according to this line or along with this line, x minus y is equal to 10. And after that, 2x minus y less than or equal to 10 is there. Equation, if you take, it will become equal to 2x minus y is equal to 10. Once when x is equal to 0, what will happen? Minus y is equal to 10 is there. Y is equal to minus 10. Again, the same point here, y is equal to minus 10 when x equal to 0. So that x equal to 0 is there on the y line already. Y is equal to minus 10 has been plotted here. Then if y is equal to 0 in this constraint, what will happen? Y goes as 0, this term goes 0, 2x is equal to 10 will be remaining, x equal to 5 in that case. So x equal to 5 where it is? In between 4 to 6, x is equal to 5 is here. Look at the cursor. So these 2 points have to be joined using straight line. Since we know the linear programming problem concept, feasible solution where we will be finding out, where it will be found out only in first quadrant, correct? That's why these two lines minus 10 to 10 and minus 10 to 5 must be extended in the similar way. The nature of the lines should not be disturbed. In what nature they are? Straight lines. In the similar nature, the straight lines have to be extended in first quadrant. So minus 10 and 5, this much was already there, straight line, and the same has to be extended further on first quadrant. And here also minus 10 and 10 is there. That straight line was of this nature. The same nature in the similar way, let it be extended in the first quadrant as straight line. And after that, these inequalities you can observe in the question. Look at the cursor. These two are less than or equal to kind. Less than or equal to in the sense for both the straight lines towards the origin I have to go. For this line, where is the origin? Origin is here. So towards origin it will be going, this line. So small lines I have shown here, see, indicating that towards the origin. And second equation is also towards the origin. Once again with the small lines, it's observed indication towards the origin we are going. And feasible region always lies in first quadrant. That's why first quadrant alone let us concentrate now. Any common area less than or equal to this line also it has to be, and less than or equal to this particular line also it has to be. Look at the cursor, otherwise you will not be able to follow properly. Here less than or equal to this line as well as less than or equal to this line, which is the area? This is the area which is found shaded in this slide, is feasible region, correct? Now you can observe once again clearly. Here extension of these two lines may happen further also in first quadrant. Am I correct? Here also again first quadrant, it can be extended further, it can be extended further. After that, extension if it is further happening both the straight lines, again feasible region also further it will be going increased this shaded area. Am I correct? Then the given problem is of the kind maximization, see, Correct? Maximization problem is given. So maximization in the sense, in this feasible region, I have to find maximum possible Z value. Maximum possible Z value, like it may fall here, it may fall here, it may fall here. In this way, it may go on increasing, because maximization of Z value, will be obtained at higher level of X and Y values. That's why higher level of X and Y values will be obtained at the highest level possible. So look at the cursor. In this way, highest level possible, when we are going, it goes an unbounded way, because feasible solution is unbounded here. Am I correct? No boundary for here feasible region. There is no boundary for that. Unbounded it is. That's why X and Y values for an increasing way, if I am observing, it goes as unbounded. So Z is increasing indefinitely here. Do you agree? Z is increasing indefinitely. That's why, it is unbounded solution, because maximized Z value we are not able to obtain in this unbounded way of feasible region. That's why the solution will be written simply as unbounded. In case the problem is given instead of maximization as minimization, then observe here, minimum possible values, at least corner points, we can find out here at this particular, the point where the cursor is there. And here also, once again, where the cursor I am showing you, here also we can find lower possible corner points of the feasible region. If it is maximization, here we will be going maximized value of X and Y. Minimization, if it is, here minimum possible values we will be coming, so that these two these 2 points we need to concentrate in order to get Z value. By putting in these 2 coordinate values, we have to get Z values, which is the minimum among them, has to be treated as the optimal solution. But in this problem anyhow, it is maximization. No need to worry about these 2 lower points. If in case minimization is given, that way it is to be solved. I said in the next problem we will come across such situation also. Let us understand very clearly in that way. Fine. So here Z is increasing indefinitely. That's why it is unbounded solution. Fine. You can observe here the cursor. From the graph, it is clear that the value of Z increases indefinitely. Therefore, the suggested solution for the given LPP is an unbounded solution. Note, in this above problem, objective function is maximization. So, solution will be unbounded. Whatever I have explained already, it's being given once again in terms of note. Since here maximization is there, it's unbounded solution. If it is going minimization problem, then the corner points 0, 0 and 5, 0. I shown you at that time these 2 points, which are nothing but 0, 0 here, and here X value is 5, Y value is 0, 5, 0. So that 0, 0 and 5, 0 must be solved by putting in objective function Z, and minimum value of Z will be considered as optimal solution, as I have already explained to you. See cursor where it is there, if you are seeing, then only you will be able to understand. Otherwise it's very difficult. As I have said, any narration has to be followed. Without following the cursor is very, very difficult. So concentrate on the cursor always. So it will be very clear in problem number 17 it's being said. Next problem we can see. Question number 17. Solve graphically minimization of z equal to 5x plus 4y subjected to 4x plus y greater than or equal to 40, 2x plus 3y greater than or equal to 60, x comma y greater than or equal to 0. See, in this problem minimization is given as underlined red ink. In the examinations it will not be given in that way, but here for your understanding it's being underlined with a red ink. That indicates you may have to be extra cautious. Okay, fine. What is the first step here once again? Observing linear inequalities as equalities first and then obtaining two sets of equations, two sets of values and plotting on the graph, finding out straight lines and then finding out feasible region and optimal solution. Okay, let's see how can it be performed. Okay, look at the cursor once again. Here question number 17 right side. For your reference it's given. First constraint 4x plus y is equal to 40 after considering equality. So x equal to 0 if it is put, what is y value? X equal to 0 means this goes as 0 and y value will be equal to 40. Y value equal to 40 where it is in the axis, y is equal to 40. Correct? On this y axis always x equal to 0, so that 0 comma 40 has been written over here. Then fine. In the same equation y is equal to 0 if you put, what happens? 4x equal to 40 is there, x equal to 40 divided by 4, then it will be 10, correct? So x equal to 10, where is x equal to 10 on x axis? Here x equal to 10 and y equal to 0 anyhow. When y is equal to 0, x equal to 10 we have obtained. So x equal to 10 is here, obviously y is already 0 on the x-axis. Concentrate on cursor always. Whenever you are not understanding anything, again go back in the video, come back once again, have the track of the cursor and then you will be able to understand. Otherwise you will not. Fine. So these two lines, these 2 points have to be joined with a straight line. And what will be the coordinate values at this point where the cursor is there? See, here is the cursor. What is the value here? 10, 0. Am I correct? 10 is the value of x and y value would be 0. Fine. Then second constraint you can observe, 2x plus 3y greater than or equal to has to be considered as equal to and then 60. So if x equal to 0, what will be y value? This goes as 0 when x equal to 0. Then y is equal to 60 divided by 3. What is that? 20. So y is equal to 20. Where it is y is equal to 20? Here the cursor shows y is equal to 20. And at this y-axis anyhow x equal to 0. Fine. And then once when y is equal to 0 in this equation, look at the cursor. Y is equal to 0 if I put in this equation, what will be x value? 2x equal to 60 is there. X equal to 60 divided by 2, which is nothing but 30. X equal to 30 on x-axis, where it is, look at the cursor once again here. This is what is 30. X equal to, and y is equal to 0 on this. Correct? These 2 points have to be joined using straight line. And once again you can observe linear inequalities in the question, that both greater than or equal to and greater than or equal to kind it is given, so that away from the origin we have to go in search of feasible region. See, away from the origin with a small lines for both the equations, lines I've shown first, and away from the origin, the common region, if we have to see, this is what is the common region. Like, it has to be extended further. This lining has to be extended further from these 3 points. 1, look at the cursor, 2, and this point 3. From these 3 points, like, away from the origin, entirely everything is feasible region. Correct? Had it been given in the problem maximization, then again it was taking the dimension maximum value towards away from the origin. If we are going, it was unbounded, and the solution was to be written as unbounded solution. Correct? But here it is given minimization. The question is of minimization. Look at the cursor. The question here, right side. So minimization is given. That's why these minimum possible points as the corner points, minimum possible, these 3 points which are responsible for this feasible region may have to be evaluated using objective function z equal to 5x plus 4y, which is the minimum among these, may have to be like, considered as optimal solution. Let's see. This is how it has to be done. Corner points A, B and C, with all those respective corner points I have written, and minimization of z equal to 5x plus 4y calculation has been performed, and z value, according to this particular calculation, z value has been calculated and written 160, 94 and 50. As I have said you can pause the video and observe the calculation if need be. Since it is minimization problem, among these obtained z values which is minimum, 94 is the minimum. So that is why in bracket it's given as MIN, minimum. This responsible coordinate values 6, 16, which is nothing but the point B, will be treated as optimal solution. That's what is being written over here. An optimal solution for a given LPP is B 6, 16 with minimum z value is equal to 94. Here it concludes the solution of 17th problem. Next, one note is mentioned. Whatever it was explained already, once again as the reminder, note is mentioned. By observing the above graph, it seems to be an unbounded solution, but it is minimization objective function here. So minimum or starting points of feasible region are to be calculated using z to find out minimum value. If in case it is given maximization problem, we would have written as unbounded solution here, as in case of 16 question. In the sense, question number 16. Both question number 16 and question number 17 gives unbounded feasible region. Again, try to understand. Both question number 16 and 17 is are giving unbounded feasible region. But one is maximization, one is minimization. Question number 16 was maximization. That's why we had written there as unbounded solution. Question number 17 is minimization. Therein, minimum or starting points of feasible region are calculated using z to find out minimum value of z as optimal solution. Fine. So these are the problems for your practice home assignments. Question number 18, 19 and 20 from your exercise. Practice well. As I have said already, the notes must be intact once when college reopens. Individually, each and every student's notebooks will be checked. Question number 9. See, already we had solved the problems in the college in classroom teaching based on formulation of LPP, and after that graphical solution or graphical method of solving LPP just now we have come across in the video, and remaining kind of problems let us touch upon and conclude the chapter. Question number 9 from your exercise. Which of the two feasible solutions 12,10 and 14,4 of an LPP maximizes the objective function z equal to 5x plus 4y is the question. Earlier in the questions of solving graphical method, using graphical method solving the questions, it was given formulated LPP. We used to take the points first, plot on the graph, take the straight lines, identify the feasible region, and after that corner points coordinate values, and then substituting in objective function. Here 90% of the work has been already completed. Corner points of the feasible region already given. 12,10 and 14,4 are the coordinate values of corner points. So that only these points substitution in given objective function and finding out the values, and since it is maximization problem, maximum value among those two available z values may have to be written as optimal solution. Fine. These kind of problems are of 2 marks. If it is given in case of graphical representation, it would be given as 5-mark problem, but here if it is this kind of problem, then it will be having 2 mark. Solution. Given objective function is z equal to 5x plus 4y. Let A 12,10 and B 14,14. Look at the cursor. Here 12,10 and 14,4, whatever it is given, let us observe as A and B. Let us substitute these values. Here 5 as it is, look at the cursor, and then in case of x 12 is being put plus 4 as it is. In place of y 10 is being substituted. 12 multiplied by 5 60 plus 10 multiplied by 4 40. 60 plus 40 which is equal to 100. And here in case of B, z equal to 5 as it is, in place of x 14. Look at the cursor and understand. Plus as it is, and 4 also as it is, and in place of y, this y 4 has been substituted. Here 14 multiplied by 5, what it is? 70 plus 4 multiplied by 4 is equal to 16. 70 plus 16 is equal to 86. So we have got now z values for both the given point of values. Since maximization problem was there, in the question it was asked, among these 2 points, which maximizes the objective function 5x plus 4y. So 100 is the maximum here. That respective values are, coordinate values are A 12,10. That's why A 12,10 maximizes the objective function. Z equal to 5x plus 4y has to be written as answer. Therefore, A 12,10 maximizes the objective function. Fine. Next. One more question. Consider the following LPP. Maximize z equal to 5x plus 3y. subjected to x plus 3y less than or equal to 10, x less than or equal to 5, and x greater than or equal to 0, y greater than or equal to 0 as the non-negativity restrictions. The real question is here. Suppose x equal to minus 3 and y is equal to 4. Is it a feasible solution to the given LPP? Give reason. We know already feasible solution is nothing but the region which is being satisfied by all the constraints and non-negativity restrictions. Non-negativity restrictions in the sense the decision variables should have positive values. Negative values should not be there. Non-negative restrictions it is. Non-negative in the sense they are to be positive. Here already given x value is minus 3. Am I correct? Look at the cursor. X equal to minus 3 when it is given, it's not at all positive value. It is a negative value. Nowhere it is to be considered as non-negative value. It is a negative value. So that it will not be a feasible solution. With x equal to minus 3 and y equal to 4, it will not be considered as feasible solution. Why? It is not following non-negativity restriction. That's why it will not be called as feasible solution. That way the answer has to be written. It is just 2-mark question. Nowhere it's required to be solved by graphical method first and then decide the inference or the conclusion. No. Directly the question has been asked by giving x equal to minus 3 and y equal to 4. Using this as a single statement, it can be written the solution. No need to unnecessarily stretch this particular solution. So in terms of solution, it is not feasible solution to the given LPP as one of the decision variables x equal to minus 3 does not support non-negativity restriction. In a simplest format, this much of answer has to be given for the given question. I hope it is clear. From LPP chapter, formulation of LPP problems are already completed as I have mentioned in classroom teaching itself. So this completes the chapter linear programming problem. Thank you so much.